Hello everyone, my name is Mohammed Abdullah Hussein, and today I will be talking about assignment 1. So this line of code is importing the fashionist dataset from the cars.datasets module in the cars library. So the fashionist is dataset collection of 6028 by 28 grayscale image of 10 fashion categories along with test set of 10,000 images. And this is the uh, 10 fashion categories from 0 to 9. Okay, so this line of code is loading the fashionist data set and assigning it to two tablets of numpy arrays. So train images and train labels, train images and train labels. So the load data function loads the data set and returns it as a pair of tablets, each containing image data and label data. The first table, train images, train labels contains the training set images and their corresponding labels, while the second table, test images and test labels, contains the test set images and their corresponding labels. So the line is unpacking the loaded data set into these two tablets and assigning them to the respective variable train images, train labels, test images, and test labels. So the first question. So what are the dimension of train images, train labels, test images, and test labels? So the dimension of the variables are as follows. So train images, which is 6028 by 28. Train labels is 6,000. Test images is 10,000. 28 by 28. Test labels is 10,000. So where 6,028 indicates a three-dimensional array of 60,000 images with each image being 28 by 28 pixels. So the dimension of train labels and test labels are one-dimensional arrays of 60,000 and 10,000 items. Okay, number 2, what are the lengths of train labels and test labels? So the length of train labels and test labels are both one-dimensional arrays, so their lengths can be obtained using the length function in Python. So here it is. So I've declared the variable length train labels equal to the length function, and then I passed to train labels. And then I printed the length of train labels are length of train, and I passed my variable that I've created, the length train labels. And same as the test labels, I use the length function and then I pass the test labels. And if I run, I should get 6,000 for the train labels and 10,000 for test labels. Okay, number 3. Please show sum of train and test labels. So to show it, this is how I did it. The first three elements of train labels array are, I say train labels 3, so this one is gonna show the first three train labels. and same as the test levels. And if we run, we get the first three elements. Okay, number 4. Please show the digital content of image index 5 in the training data set. So this is how I did it. I printed the training image index 5 and this is the result. Number 5. Please plot the image of the index 5 in the training data set. So I used the matplotlib to plot, and I used plt.imshow. Then I passed the train image in index 5. So this code will display the fifth image in the train dataset using matplotlib's imshow function, which stands, I believe, image show. The CMap argument is set to gray to display the image in a grayscale. So, sorry. The show function is then used. This show function is used to display the image, as you can see here. Number 6, what is the label for the index 5 in the training label? And looking up in the above list. So to print the label for index 5, I use the print function. I say label for index 5 and I pass train labels index 5. So as we see here, when we print, we see here the label for index 5 is 2, which is pull over. Number 7, please show the digital content of image index 500 in the testing data set. And to show the digital content of 500 place image in the testing data set, I use the print function. I say test image 500 and this is the result. Number 8, please plot the image of the index 500 in the testing dataset, and I imported the matplotlib and I used the plot show. So this code will display the fifth 500th image in the testing dataset using matplotlib imshow function, which is image show function. So the CM argument is set to gray to display the image in a gray cell. So the show function is then gonna print the image, as you can see here. Number 9, what is the label for the index 500 in the test label? And looking up in the above list, what does it mean? So the label for the index 500 in the test label can be obtained by accessing the 500th element of the test label array. I create a variable called label, then I assign to test labels, then I pass 500, and then I printed the label. So for this case, so t-shirt is 0, trouser is 1, pullover is 2. So number 10, please import models and layers from the Keras library. To import the necessary modules I used here from Keras modules import. So I imported all the necessary. So in this code, we are importing the sequential model from the Keras models, which is a linear stack of layers where you where you use the large majority of the models. We are also importing the dense and flattened layers from the Keras layers. So the dense layer is a fully connected layer which is standard feed for feed forward layer for deep learning modules. So the flattened layer is used to flatten the multi-dimensional output of previous layer into a single dimension, which is required by subsequent dense layer. Number 11. Define a sequential model and call it my network. So here I say my network is equal to sequential, and then I pass here is the what we need. So number 12. Reshape the image from 28 by 28 to one column with 784 neurons flaring. Use two methods, one from the book and one from the 20 minutes video. So method one from the book, train image is equal to train image dot reshape 6000 comma 784. Test image is equal to test image reshape 10,000 784, and test image array from 6000 sorry. So that's method one from the book. Method two from the video, train images is equal to train images dot reshape 6700 test image dot reshape 10800, and then I printed the test image. Okay, next. Also, please normalize the image by dividing the image by 255. Use two methods. Okay, so I said method one from the book, train image is equal to train image dot as type float 32 255. Test image is equal to test image dot as type float 32 divided by 255. Method two. So I use train images is equal to train images divided by 255.0. Test images is equal to test images divided by 255.0, and then I printed the train image. So this code is equivalent to the first method, but we directly divide the train image and test images arrays by 255.0 instead of first casting the data type to float 32 and then dividing. Note that in this case 255.0 is a floating point number. And here's the answer. Number 14. Add one hidden layer that has 512 neurons using ReLU activation function. So here I say 512 I passed here. Number 15. Add another hidden layer that has 128 neurons. So this is how I use my network.add dense 128 activation ReLU. Number 16. Add the last layer as a 10 neuron. So this is how I did my network.add dense 10 neuron activation softmax. Why we use softmax for the last layer? So I said the soft max function is used in the last layer of classification model to convert the Morris raw output into probability distribution over the possible classes, making it easy to translate and use for prediction. Number 17. Use the following two settings for the compiler and run them separately and see what the difference are. So optimizer, the first one, Atom, loss spare, this one, and matrix, and reach loss function. So these are the two settings for the compiler that we have to run. And here I define the model. So I say my network is equal to sequential, and then I said add 512 activation value, and then I'm compiling the model. So we're using the first one here, Atom, the first optimizer, and then we're training the model with the first set of settings. I say my network.fit train images, train libraries, okay, and then we combine the model with the second set of settings. And here I'm just printing my variable, my network, and here is the answer. Trying to run, okay, it's gonna take time. Okay, let's go to number 18. Now after the compilation, please try to find the pattern using the fit command. So the images need to be 10 for this example. So here I used my network dot compile optimizer. I passed the first method we had here, and my network dot fit. Then I pass my train images, train labels, and then I'm just printing the network. And if we run, we're just gonna get this one, but it will take time like this one. But we should get like this. Number 19. How do you compare the fashion MNIST with what we learned in the class using the MNIST? So what we can infer from the differences in the accuracy, what could be the reason for that? So I said fashion MNIST is an alternative to the traditional MNIST dataset, but with a different set of images and categories. Fashion MNIST is considered a bit more challenging than the original MNIST, and it is common to see lower accuracy on the fashion MNIST compared to MNIST. There are several reasons why this might be the case. First, the images in fashion MNIST are more complex than the handwritten digits in MNIST, with more interactive intricate pattern and finer details. This means that it is more difficult for the model to learn the features that distinguish one class from another. Second, the increased complexity of the images, meaning that it is also more difficult for the human to label the images accurately, which could result in a higher level of noise and incomplete in the data. So in conclusion, the difference in accuracy between fashion MNIST and MNIST can give us insight into relative difficulty of two datasets and highlight the importance of using appropriate training dataset for a given task. Number 20. So let's, okay. Number 20. Now after completion, please try to find the pattern using the fit command. The epoch needs to be 10 for this example. Okay, so this will start the training process where the model will learn the classify the different types of clothing items in dataset. So I don't need this one. I already have it. I already declared. So here we are define the model and we are combining the model with the first set of setting. So if I run, okay, this is gonna take time. Okay, let's go to 21. How do you compare the fashion list with what we learned in the class using the list? So what we can infer from the difference in the accuracy, what could be the reason for that? If both fashion list and list are image classification datasets, their content is differ. Minutes is made up of images of handwritten numbers in grayscale, whereas fashion minutes is made up of pictures of clothes in a grayscale. In terms of accuracy, we can see that fashion minutes is more difficult dataset than minutes since even when employing the same kind of training algorithm, fashion accuracy minutes is typically lower than MNIST. This might be because fashion MNIST images are more variable and contain pretty patterns, textures, and shape compared to MNIST digits. Additionally, clothing items may be harder to categorize because they may not be as unique from one another in terms of their colors, textures, and shapes. Okay, number 22, the last one. Use the evaluate to calculate the achieved accuracy and loss over the test images and labels. And do we have a overfitting? So here I say test loss, test act equal to my network, which I already declared my variable, my network. Then evaluate test images, test labels. And then I printed text accuracy is test accuracy, test loss, then I said test loss, and this the answer when if I run. So the test accuracy is 0.85, test loss is 0.41. That's it for assignment 1. Thank you for watching. Have a lovely night. Bye.